Okay, so here we're asked to find the acceleration parallel to the plane, right? For part A, for example 6, right? And we're given this information here. 2 kilograms, the force is 15 newtons with this structure here, right? So we have here an object. It has a weight force, and the normal force is going to be perpendicular to the surface, right? So we know that, and so now we have to find the acceleration of this, right? Oh, another something very important, I forgot to add. The force is going this way, it's being pushed that way, right? So that's the positive direction there. Sorry, that's the negative direction. The positive direction would be this way, because that's the way it's going to fall. Right? Alright, so it has to be parallel. So we're looking for something that's parallel to this plane right here, right? And we're going to call that the x prime plane, because it's like in the x-axis. If you look at this and this is like if it was in the x-axis. So then knowing that, we know that over here, this force kind of going this way is gonna be equal to this. The sum of the forces in the x prime is gonna be equal to the weight force times the sine of theta, right? And we also know that the sum of the forces of the x prime is equal to mass times acceleration, right? So now we're just gonna put the forces that we know, which is the weight force sine of theta minus the f equals mass times acceleration, right? And then you get, if you solve for m, if you isolate for the acceleration by dividing m to both sides, you get this, right? The gravity sine of theta minus f divided by m equals acceleration. And then when you work it all out, you should get, oh, this is actually wrong here, my apologies, this should actually be 2.5. when you work it all out, should be 2.5, right? 2.5 meters per second, right? So that's what you should get. Okay, so for part B, it's asking for let me just check here just in case, to find the force that I need to have the acceleration equals 0. So I have to make that the acceleration be 0, right? What force is that? Okay, so we know that here, this force here is going to be mg theta, right? Mg sine of theta. Sorry, I should say sine. Sine of theta. Sine of theta. Should say sine right there. Sine. Okay. And so knowing that, we have this equation here. We have that mg, so now we just equal all the forces. Let's write out all our forces. And we have mg sine of theta minus the 15 plus the force that we don't know, and that equals ma, which we know has to be 0 because the acceleration is going to be 0. So now if we plug in all those numbers, you have 10, which is your mg sine of theta, minus 15 plus f equals 0. Once you work it all out, you're going to get that the force is going to be equal to 5, which makes sense, because if you see here, if you have here 15 plus the 5 plus the 10, they should cancel out, so your acceleration is going to be 0. So that should work out. That's for part B.